So this 180, when you go 180 divided by 180, you get 1, right? So you just write pi. 210 divided by 180, you get 7 pi over 6. 225 divided by 180, you get 5 pi over 4. 240 divided by 180, you get 4 pi over 3. 270 divided by 180, you get 3 pi over 2. 300 divided by 180 is 5 pi over 3. 315 divided by 180 is 7 pi over 4. And then 330 divided by 180 is 11 pi over 6. And then 2 pi. Because 360 divided by 180 is 2, and you add the pi to it, right? So I always do my degrees first based on my reference angles, and then I convert to my radians right away. Does that make sense? Now those are just the angles, the interior angles of your unit circle, correct? Your unit circle has a radius of what? Do you remember? Anyone? It's 1. So it has a radius of 1. So the coordinates, and if you didn't know this, the coordinates on the outside actually just represent where that coordinate would be on a Cartesian plane. Your unit circle is embedded on a Cartesian plane. Like this is the y-axis, just so you know. That's the y-axis. That's the x-axis, correct? And this unit circle has a radius of 1, and it's just embedded on this Cartesian plane on your xy axis, right? Now, on this unit circle, people will tell me there's only these coordinates. Actually, no, there's not. There's one here, 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 one here. There's infinite points along this unit circle, correct? Like I could say, what's the coordinate at 1 degree? And there's going to be a coordinate on this unit circle at 1 degree. It's very low above this x-axis, but there is one. We just only ask exact values of coordinates at 30, 45, 60, and 90 reference angles. So we only look at these ones, but there's infinite, for sure, 360 degrees of coordinates around this whole circle, right, that I could ask for. If I ask for exact values, I have to ask for 30, 45, 60, and 90 reference angles. So we know that this circle is embedded on the Cartesian plane. I know I have a radius of 1 in all 4 directions, correct? So I can do those coordinates the fastest. If I want to do this coordinate, what the heck is this coordinate? How far over am I? 1, how far up am I? 0. So it's 1, 0. That's the coordinate of that point, right? We need not memorize anything. We should understand why. If we understand this unit circle better than memorizing, you will do really, really well in this unit because you'll actually understand it. Therefore, you can apply it, which is what we have to be able to do, is to apply this unit circle. If I go to this one, here's 0, right? I go how many up? 1 up. How many over did I go to get to this coordinate? 0. So I'm over 0, and I'm up 1. What about this one? Where's this coordinate as opposed to the Cartesian plane y and the x, the green and the red? Yeah. -1 and 0. And then what about this one down here? What's this coordinate? 0 and -1. Did I have to memorize anything at this point? No, I have to understand why. I'm telling you, we have to apply and use this unit circle all the time. We better just know what the heck it even gives us rather than just memorizing it. Memorizing it is a tool, but if we understand why we're getting what we're getting, it makes life so much easier. Okay. Now, we know that this is a Cartesian plane, correct? So what we're going to do is we're going to go to all the coordinates, and before I even figure out what the heck they are, I always do my degrees, I do my radians, I do my coordinates at those top sections because they're the easiest. And then what I do is I actually go through and I actually make all the signs for my coordinates before I even find them out. So in quadrant 1, Both of my x and y are positive, correct? So I don't need any signs. That's good. They're signed up. In quadrant 2, y is positive, but x is negative. So I need to go like this. Put in some negative signs. Because my coordinates in that quadrant are going to have negative x's. We agree? What about quadrant 3? Quadrant 3, what? They're both negative. So I have to go in and do this. And why am I doing that before even finding them out? Because that's when people mess up. They forget to put the signs. And in quadrant 4, x is positive, but y is negative. Okay? The 45-degree reference angles are the easiest. They're root 2 over 2, root 2 over 2. Can you type root 2 over 2 into your calculator? That's not annoying at all. What's root 2 over 2 is a decimal? 0.707, right? Okay. Let's go back to our realistic looking unit circle here in front of our faces. So, most people will memorize that the 45s are root 2 over 2, root 2 over 2. All the 45s are. But the reason why they are is my y, does that look like a height of 0.707 if this whole thing is 1? And my x is at a length of 0.707. Are they the same distance away from the x and the y? They are. That's why the 45s are both root 2 over 2. Because if you look, it's 0.707 to the y, and it's 0.707 to the x, because I'm literally finding out what the heck this value of this coordinate is. Do you agree? So I can go to every 45-degree reference angle and now just put root 2 over 2, root 2 over 2 the whole way through. Because I have my signs. So this one's root 2 over 2, root 2 over 2. This one is root 2 over 2. This one's root 2 over 2. Because they're the same distance, right? Then comes the people not remembering if it's half and root 3 over 2 or if it's root 3 over 2.5. And you're like, oh, which one is it? I don't know. Remember, it's a coordinate, correct? That coordinate is drawn on the Cartesian plane. So let's look at this first one. Now, just an aside, a half is 0.5, correct? So that would be half the distance of the radius, yeah? Root 3 over 2 is my other option. And it's 0.8660, I believe. It's something like that. Okay, so it's almost 1. Right? It's 0.866. It's higher than 0.707, which was root 2 over 2. So let's look at the first one here. Let's look at the 30-degree reference angle. So I'm going to look at this coordinate. People will do this all the time. Don't do this. They'll go, I can't remember if it's a half and root 3 over 2. Or if it's root 3 over 2.5. Dang it, do I go 2, 2, 2, 2, 2 over 2s, and then do I go 1, 2, 3, and then 3, 2, 1, or do I go 3, 2, 1, and then 1, 2, 3? If you're that person, you can make an oopsie, right? If you don't remember if it starts with the x and I go up by 1, 2, 3, like, that's scary to me. It's a coordinate. You guys are brilliant people. You guys can do this without memorizing up and down. We memorize in grade 11, so you guys got some numbers down, and then we understand in grade 12. That's what we do. So let's look at this coordinate here. This coordinate is on this Cartesian plane, correct? This x, is this x 0.8660 or a half? That looks like 0.8660 to me, doesn't it? It doesn't look like a half. So which is it? Is it a half and root 3 over 2 or root 3 over 2.5? Root 3 over 2.5, because where's my y? My y comes across here, and what does that look like to you? Half, doesn't it? So my x is root 3 over 2, and my y is a half. It's a coordinate. It should make sense. Like if you sketch it, it should be a half and 0.8660. Now all of my 30s are that. So just like all of my 45s, I went and did root 2 over 2, root 2 over 2. All of my 30s are root 3 over 2.5. So I can just go fill them in. Root 3 over 2.5. Root 3 over 2.5. root 3 over 2 and a half. What's the 60s just? They just split. And let's see why. If I go to the 60, what does this x look like? Halfway, hey? So my x is a half. And what's my y? That looks like 0.866 to me. So it's root 3 over 2. So that's why they flip. Because a triangle flips, that special triangle you learn about. So we get a half root 3 over 2 for all my 60s. A half root 3 over 2. Half root 3 over 2. There is no reason why you should get any of these wrong. For two reasons. One, you can literally see where it would be drawn, right? A half root 3 over 2. Second, you can check every single one of these with your calculator. Does anyone remember what coordinates, what they go in order at all? Do you know what they represent for cosine, tan, anything like that? Does anyone remember the coordinates? The coordinates all represent Calgary Stampede, coast and sine. So every coordinate on your unit circle, you don't even know this, every coordinate on your unit circle is the cos of that angle, the sine of that angle. So every coordinate on this unit circle represents cos theta, sine theta. Actually what each of these are. The x answers are every cos of every angle. The y answers are every sine of every angle. You can check them with your calculator. Okay? So we're going to check it, yeah?
Can we have the tans down this page?
No, because the tans you're going to do sine divided by cos, which we're going to do later. So we can get every trig ratio. There's also 3 other secondary ones, cosecant, secant, and cotan, which we're going to talk about. Every single one of them you can pull off this unit circle. But the ones you can pull off instantly are coses and sines. So let's try it out. Let's go to a random one. 5 pi over 6. If I'm going to type in 5 pi over 6, guys, what mode do I need to be in? Radian. Okay? If I'm typing in 150 degrees, what mode do I need to be in? Degrees. So it really matters. So I'm going to make you guys be in radians for now. So go to mode and radians. Everyone should have their calculators in their hands. No phones out. So you're going to go to your mode and you're going to go to radians. Everyone there? We're going to try this one out. So I'm going to go cos of 5 pi over 6, comma, sine of 5 pi over 6. This is what I should get from my coordinate. That's what my coordinate should be. Cos of 5 pi over 6, sine of 5 pi over 6. So type cos of 5 pi over 6 in your calculator. What do you get for an answer? Negative 0.8660. What the heck is that? Negative root 3 over 2. You're just guaranteeing that you didn't make a mistake, right? Now type in sine of 5 pi over 6. What do you think you're going to get? Hopefully 0.5. Did it work? Okay, I want you guys to check 330 degrees. What are you going to have to do first? Go to your mode and change it to degrees. If you're pressing cos or sine, slap your hand first and be like, wait a second, what do I need to be in, degrees or radians? I told you for this one 5 pi over 6, so you had to be in radians. For this one, I'm telling you now to find 330. So we're going to go cos of 330 degrees, sine of 330 degrees. How could you keep it in the same mode that you were in before? How would you have not had to convert it to degrees? What would you have had to use instead? 11 pi over 6. You would have to use radian. This means the same thing, right? If you don't put them in the right one, though, in your calculator, you're going to get it wrong, and they'll have the answer to the radian, or the degree off. Oopsie, there. So the moment you go to press cosine or tan, stop yourself and be like, what mode do I have to be in? If I'm going to press 330 degrees, I need to be in degree mode. If I'm going to press 11 pi over 6, I need to change it to radian. Okay? So before you go and press those 3 buttons, you have to stop yourself immediately and say, what mode do I need to be in? Or it's going to be ugly. And it would be really, really easy to forget that. Except we're doing this for like a month, so you won't forget it by the end. But you have to remember right away now, when you press the sine, cos, and tan, no more can you just press those buttons. Before you press them, you have to think, what mode do I need to be in? No more reset it to degrees and just float. It ain't happening. Okay? So when we type these in, when I type in cos of 330, if I'm in degree mode, it gives me 0.8660. If I'm in radian mode, it does not. It gives me something else, and it's not this. And you'll think you're wrong, but you're not. You just don't have the right mode. Sine of 330. So every single one of these, could I just use my calculator and find them? Yep. When I'm done my unit circle, I do checks. I go along and I check like 4 different points just to see if I'm right. Make myself do it. Okay? Does everyone understand how to set up the unit circle? You have to be able to do it on your own. You can't take a filled-in unit circle to your unit test. I'm being nice and even giving you one to fill it. Okay? You have to be able to do it. Where do the errors lie? Memorization. People will try and memorize. Memorizing scares me because you might memorize backwards or something, right? Or which one do I start with? Okay? And 2, forgetting the signs. They forget to put the signs on the points. Just don't forget that. Okay? All right, we're going to go to our notes. Section 4.2. The unit circle. So some of this is going to be a repeat because you kind of, I treat it as if you are just learning for the first time, but you have seen the unit circle in grade 11. What detail, I don't know, because some of you are distance learning, which is totally fine, but you've seen it, you maybe just didn't memorize it as if you were in class. Because in class, it's drilled into your being, into your soul. At least if anything, it's memorized. Okay, the only thing that you're missing is radians, usually. You don't get taught that unless you're an AP. So, the key thing, when I say is a factor in polynomials, what should you think? When I say is a factor, what should pop into your head immediately? Yeah. Sorry, I can't hear you. Yeah, your remainder is 0. So if you hear is a factor, remainder is 0, you set t of x equal to 0 and you can solve it, right? That's if it is a factor, remainder 0. If I say x-intercept, you immediately think y equals 0. If I say y-intercept, you immediately think x equals 0. If I say constant in polynomials, you immediately think y-intercept, right? That's what you should be thinking. In this unit, if I say, and I'm going to write this in red because that means important. If I say on the unit circle, you will immediately think, I need to use the equation x squared plus y squared equals 1, and I'm going to tell you why. So, if you hear on the unit circle, you're going to think x squared plus y squared equals 1. You're going to think, I have to use that formula. Why? Well, I'll give you a little info. A circle formula is x minus h. You don't have to write this, I'm just explaining where it came from. X minus h squared plus y minus k squared equals r squared is the formula for a circle. It used to be in conics, 2011, before 2012 when the new curriculum came in. There used to be a unit in grade 12 called conics. And you had to come up with hyperbolas, and you had to do equations of circles and ellipses and all that jazz. We don't have that anymore. All we need to know is to use x squared plus y squared equals 1. But once again, if you don't understand why, you're just memorizing, and that scares me. So I want you to understand why it's that. So h and k represent the center of the circle. Okay, you would fill these in with values if the center of the circle moves. So if the center of the circle was at 1, 1, I'd have x minus 1 squared plus y minus 1 squared equals my radius squared, right? What's the center of the unit circle at? 0, 0, right? So what do these become? Just zeros. And what happens when you minus a 0 plus a 0? Nothing. You get x squared plus y squared, which is what I have, right? Because the unit circle is centered around 0, 0. If it was centered somewhere else, I'd have numbers there, but I don't. Now, why is it equal to 1? Like, I have equal to 1 up there. Yeah. Because the radius of the unit circle is 1, and the formula for circles is r squared, and 1 squared is just 1. That's where the formula comes from. I don't want you to just memorize, I want you to understand. So it's x squared plus y squared equals 1 is the formula of the unit circle. So if you're ever given an x on the unit circle, you can find a y by plugging it into that formula. If you're ever given a y, you can find an x by plugging it into that formula. Okay? That will come up later. For right now, you were taught that you could use special triangles in grade 11. That's how you were taught how to come up with the unit circle, right? You use your special triangles, and if you went for cos of 60, which was x, cos of 60 is, cos is extra, you don't do it that way, as adjacent over hypotenuse. I want to do our x's and r's, which is what you're going to do this year, but you'll get it. So it's, I keep thinking cos extra rice. Sorry, you'll be saying that in a week. You'll be fine. You'll be with me. It's ka. Cos is adjacent over hypotenuse. So ka toa. So you have adjacent over hypotenuse. Adjacent would be 1 over 2. So that's why cos of 30 is a half. Or cos of 60, sorry, is a half. Cos of 30 would be over here. And this would be my adjacent over hypotenuse. And that's why it's root 3 over 2. That's where you're getting those numbers on your unit circle from. It's from the 30, 60, 90, and 45, 45 triangles, which you would have learned in grade 11. Just a little summary. Okay? Now, we know if the circle has a radius of 1, we can come up with these coordinates very easily, correct? But could I still check them using my calculator like I told you before? Yeah. Could I go cos of 90, and it'll give me 1, and sine of 90, or cos of 90 gives me 0, sine of 90 and it gives me 1 if I'm in degree mode? Yep, it'll do that. So I can still check them all. This is just a reminder from last year. This is all a reminder from taught last year. Okay? So, this year, state the coordinates of the intersection of the terminal arm and the unit circle for the following. So, we need to give the coordinate at that terminal arm. We have coordinates all around that unit circle, correct? We just filled a whole bunch of them in, did we not? Okay? So I want the point at pi over 2. So go to pi over 2, and you tell me what the coordinate is. Off your unit circle. It's right in front of your face. 0, 1. Boom. Easy answer. Right? Didn't even have to think. Just went to my unit circle, went to pi over 2, 0, 1. Boom. Got it. What we need to do is there are going to be questions on your unit test, on diplomas. There's going to be questions that don't fall right off that unit circle, right? They might be a coterminal angle outside of it. Yeah? That's why we learned coterminal angles the last day, because we can turn these into an angle that's actually on that unit circle. Give me an answer, boom, I'm done. Okay? So let's look here. We have negative 3 pi. Is negative 3 pi on your unit circle currently? No, you actually have no negatives on your unit circle. Can I find its coterminal that is on your unit circle? Yep. How do I get myself to the positives? What am I going to add to negative 3 pi? Remember when it's radians, you add 2 pi, and when it's degrees, you add 360 degrees, right? So you can either subtract 360s for life, add 360s for life, subtract 2 pi's for life, add 2 pi's for life, and you're going to get a coterminal that lands on it. Why? Because if I have an arm here, and it's in degrees, 360 is going to go boom, 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 360 plus that, right? I'm going to land right back on it, because 360 just rotates at a full rotation. 2 pi just rotates at a full rotation if it's a radian. We agree? So negative 3 pi, before I give an answer to this, I'm going to go negative 3 pi, and I'm going to add 2 pi to it. What do I do with the pi's when I'm adding these? Ignore them. Pretend they're not there. What's negative 3 plus 2? Negative 1, and then we bring our pi back. Is negative 1 pi on my formula, on my unit circle? No. Now what can we do? That's not on, so we have to keep going. We have to add 2 pi again, right? What's negative 1 plus 2? 1 pi. Is 1 pi on my unit circle? Yep. What's the coordinate there? Negative 1, 0. I got my answer. Why is that true? Because p at negative 3 pi would actually equal p at negative pi, which would actually equal p at pi. Because they all terminate on the same spot. So they're all going to have that same coordinate, right? So the hardest part on most of these is finding the coterminal angle that lands on the unit circle. 7 pi over 2, is that bad boy on there? No. Is it too big or too small? It's too big, right? If it's not on there and it's positive, it's too big, I have to subtract. If it's not on there and it's negative, it's too small, I have to add, right? So if it's a negative, I'm going to have to add to get a coterminal on that unit circle. If it's a positive and it's on the unit circle, it's too big, I'm going to have to subtract. So I'm going to go 7 pi over 2, subtract 2 pi. So I could just go 7 over 2 in brackets minus 2 without the pi's, right? And it'll give me the answer in my calculator. Or I can actually do the math by making common denominators. 7 pi over 2 minus 2 pi over 1. I'm going to have to multiply this by 2. 7 pi over 2 minus 4 pi over 2 equals 3 pi over 2. So that's its coterminal. So P of 3 pi over 2 is going to give me the exact same answer. Is 3 pi over 2 on my unit circle? Yes. It's the same as 270. What's the coordinate of that? 0 and? Negative 1. 720, is that on my unit circle? The unit circle maxes out at 360. So it's too big. So now I can go 720 minus 360. I don't have to use pi's because it's not radians. And I get 360, which is on it. So a point at 720 is the same as the point at 360. And that is 1, 0. You guys are going to try all of these except G. See how you do. Okay, if we go to 60, is 60 on the unit circle? Yep. What's it going to be at? Sorry? Yeah, and? 3 over 2. 7 pi over 6. It's going to be at?
Negative 3 over 7.
And?
Negative.
Yep. It's in quadrant 3, they're both negative. 240 is going to equal negative a half and negative 3 over 2. 120 is going to be negative a half and 3 over 2. Now, negative 5 pi over 3 is not directly on my unit circle, right? So I can go negative 5 pi over 3, it's negative. So I can add 2 pi, which if I want a common denominator, I'm going to have to multiply by 3 over 3. So I'm actually going to get negative 5 pi over 3 plus 6 pi over 3, which equals pi over 3, which is the same as 60, so it's actually the exact same. What did I teach you? What did I just teach you? Do you have to do it this way? What did I teach you with your calculator? Every coordinate on that unit circle does what? X squared plus y squared equals 1. What else? What else could I teach you with your calculator you could do every single time? Every coordinate is Calgary, Stampede. So every coordinate is cos and sine. So instead of finding the coterminal, which I'm forcing you to do because I'm making you practice finding coterminals, did you actually have to find the coterminal? Could you have just went cos of negative 5 pi over 3 in what mode? Radian. And sine of negative 5 pi over 3. Could you have done that for every single question that I didn't teach you to do it this way, but wanted to see if someone would discover it that way? Yeah, you could totally do it this way, right? Cos of negative 5 pi over 3, when you type it into your calculator, gets you a half. Sine of negative 5 pi over 3, when you type into your calculator, gets 0.8660, which is root 3 over 2. So there are two ways you can do this? Yep. Your calculator can always check it, right? What if they ask for an algebraic approach? You're going to have to show the coterminal part of it. Find out the unit circle. 19 pi over 6, so I could have just went cos of 19 pi over 6, sine of 19 pi over 6, and wrote it like that. That would actually be the coordinate, wouldn't it? They could fight you on it. You'd be like, well, look at it, I found the answer. It's perfect. They said exact values. You didn't give it to them, but they're like, I'd be like, looks like a coordinate to me. Doesn't it look like a coordinate to you? It is. The way I showed you to do it, though, is it's too big. So you'd have to subtract 2 pi. Making a common denominator, you can multiply by 6. Or just taking them without the pi. 19 pi over 6. Subtract 12 pi over 6. Gets you 7 pi over 6. Which, if you didn't notice, is the exact same one up there. Yep.
Do you ever come across like a multiple choice question where that is like a possible answer?
Yep. Absolutely is. They'll ask you for a they could ask you for a coordinate. This throws people off like crazy. So on the test, they could say, determine the coordinate on the unit circle at 33 degrees. Do I ever get people mad at me? That is not on the unit circle, no matter how coterminally I do that. If coterminally doesn't coterminal onto that unit circle you gave me, you're a horrible human. Why would you give me that? Right? Even worse when I give you like 5 pi over 9 radians. Well, then you're blown because you don't even know that that's a degree that doesn't land on there. You're trying to coterminal it, ain't finding it. Remember that radians, unless they're over 2, 3, 4, and 6, are not going to be found on your unit circle, right? Because that's a great thing about radian measure. Remember, its reference angles are, if it's over root 3, if it's over 3, it's pi over 3 radian, 4, right? So if it's like over 9, and you're not finding it on your unit circle. But, how do I get the coordinate for that? Yeah.
Cos 33 sine 33?
Cos 33 sine 33. Type it in and give me a decimal. Literally the whacked way they ask you to find that question. They ask for the coordinate on the unit circle 33. Remember I told you there's an infinite number of coordinates on that unit circle? Infinite. It's not just it doesn't like just start at 30 and then start at 45 and then start at 60. But that's the only places they can ask for exact values at. Because the exact values are root 3 over 2 and a half and root 2 over 2. Those are exact values. So if they ask for exact values, it has to be found on the unit circle at those lovely reference angles, correct? But they can ask you for any degree or any radian.
Let's go to the bathroom.
Yes. So don't fall to 33 degrees, what's the coordinate on the unit circle, and freak out because it's not on the unit circle. It is on the unit circle. It's not on your unit circle, but it is on the unit circle, right? Every degree is on the unit circle. I could ask you for what's the coordinate on the unit circle at 3,372 degrees. It's on the unit circle somewhere. You're just rotating a whole lot, right? But you would just go cos 300, I don't remember what I said, 3,372. Thank you. My brain stopped. Good thing yours kept going. You'd have to go cos of that sine of that. Boom. Give me the decimal. Okay? Alrighty. Because you have a test tomorrow, I'm going to give you the little teeny tiny amount of homework tonight. You can finish now. I'll even put the questions up on the board. It is page 187, number 4. Finish them now so you can study today. I'll write them down on the board. So they just, for this part of the textbook, I just want, it says, if P is a point on the intersection of the terminal arm of angle theta and the unit circle, determine the exact coordinates of each of the following. So it's exactly what we just did. Okay? So 4A is P of theta, B is P of negative pi over 2, C is P of pi over 3, D is P of negative pi over 6.